The bulk of gas exchange is determined by one chemical reaction, which is reversible. So before we talk about how it works in gas exchange, we need to talk about how reversible chemical reactions work. What makes them go one way or another? So first, let's look at the reaction. This reversible reaction starts with carbon dioxide and water. Carbon dioxide and water combine to form H2CO3, which is carbonic acid. H2CO3 then splits apart to form a proton, H+, and a bicarbonate ion, HCO3-. Now, depending on the circumstances, this reaction can also go back the other way. So H+ and HCO3- can combine to form H2CO3, or carbonic acid, and that can split apart to form carbon dioxide and water. So how do we know which way the reaction is going to go at any given moment in time? Well, to explain it, I'm going to use an analogy of a bathtub. So I want you to imagine that learning chemistry is very much like relaxing in the bathtub, and then you'll have the hang of it. So let's say, for the sake of argument, that we have a very fancy bathtub. So it's a fancy clawfoot tub. It's so big and fancy, in fact, that it has a faucet at one end and a faucet at the other end so that you can fill it faster. And because it's so big, we also need to have a drain at one end and a drain at the other end in order to be able to empty it faster. So if I turn on this faucet, we know that water is going to go into the bathtub, but we know water doesn't stay where you put it, all right? Liquid doesn't. So if I put water in on this side of the bathtub, it's going to move. And what direction is it going to move? That way, right? If I turn on this faucet, water is going to come into the tub, and it's not going to stay exactly where we dropped it. It's going to move, and it's going to move this way. Right? If I open this drain, water is going to leave the bathtub, but it's not going to just take the water that's above the drain. All the rest of the water in the tub is going to move toward the drain and leave the tub as well. If I open the drain on this side of the tub, water is going to leave the tub, but the water in the tub is going to move this direction toward the drain. All right? So water coming in on this side will move in that direction. Water coming in on this side will move in this direction. Water leaving the drain on this side will make the water move in that direction, and water that's leaving on this side will make the water move in that direction, right? So the same thing is true with a reversible chemical reaction. If I add reactants to this side of the reaction, so if I add carbon dioxide and water, if I put more of that into the system, into the tub, then the reaction is going to go this way. So it's exactly like adding water. So if I'm filling the reaction by adding more of these reactants, the reaction's going to move this way. If I add protons and bicarbonate to the tub, if I fill the tub from this direction, then the reaction will move this way. If I remove CO2, so I'm letting CO2 go out of the drain, if I remove CO2, then the reaction's going to move in this direction to create more CO2. If I remove bicarbonate and proton, then the reaction's going to move this direction. All right, so if they're leaving out of the drain, then the reaction goes this way. All right, I hope that made sense. That is known as the law of mass action, and it's exactly how chemical reactions are controlled in the cell. It's determined by the concentration of the reactants on either side.